Hello and welcome. So in these videos I'm going to go over some examples related to the problems that you are working on in problem set 1. Right? So problem set 1 problems have to do with just looking at units and how units are related to each other. So you're going to encounter problems that you will have to use some sort of formula that might be given for you, or that you might have to look up, or that you know from the past, and it will involve multiplication and division, kind of basic operations, but you have to be very careful about the units. Okay, so let's look at this problem right here. So a marathon runner passes the 1 mile marker of the race with a clocked speed of 18 feet per second. If the marathon is 26.2 miles in length and the speed is maintained for the entire race, what will be the runner's total time? Okay, so we're talking about running, distance and time and speed. So we do need a formula for to solve this problem, and the basic formula is that distance equals rate times time. So we have distance equals rate times time. I call this the dirt equation, right? Dirt. All right. Anyway, so the rate is the speed. All right. So what do we have here? We know that the distance is 26.2 miles. That's the total distance for the race. So D is 26.2 miles. All right. And again, very important that you write the units. This is probably where most people get stuck, or this mistake make, is kind of not having the same units on your quantities when you plug them into the formula. All right, so the speed or the rate here is 18 feet per second. All right, so here the units are not the same, right? So if I'm plugging these, this is in miles and this is in feet per second, I need to change either one or the other to match. Okay, so we're gonna look it up. How many feet are in a mile? So you can Google this, you can look it up in a book, but I happen to know that 1 mile is 5,280 feet. Okay, so here's the conversion between miles and feet. Okay, so probably the easiest thing to do is to convert the distance into feet. All right, so you're going to have the distance is 26.2 miles, and 1 mile is 5,280 feet. All right, basically, to figure out whether you're multiplying or dividing, you want to cancel out the original unit and maintain the unit that you want to change it to. So we have 26.2 times 5280 gives me 138,336 feet. So that's how many feet are in a marathon. Okay, cool. So now let's plug into the formula, because we got to figure out what the time is. That's the only unknown there. All right, so we're going to plug in. We have 138,336 feet equals 18 feet per second times time. To get time by itself, we're going to divide by 18 feet per second. So this will cancel out. All right, so I'm going to divide by 18. And we get 7685.333 repeating, and feet cancels out, and 1 divided by 1 over second becomes seconds. All right, so this is the time in seconds, 7,700 seconds. Doesn't really make sense to measure the time for a marathon in seconds, so let's change it into hours. Okay, so there are 3,600 seconds in 1 hour. So if I divide this 7685.3 repeating by 3,600, then that will tell us how many hours there are. So 2.13 hours. All right. Again, if you want to be picky and say, let's have hours and minutes. All right, so this is 2 hours. All right, and 0.3 of an hour times 60 minutes. 0.13. Actually, I'm going to keep all the decimal places in there. Times 60. That gives me 8 minutes. So 2 hours and 8 minutes for that marathon. Wow, that's a quick marathon. Wow. Anyway, that's it. All right, let's look at another example. And these examples that I'm doing come from the book, the pre-calculus book, the second one on the list. And if you read through the textbook, there's more explanation there. I just want to make videos of them from my point of view, so you can have like a video solution of those examples too. Okay. So a sphere of gold, solid gold, has a mass of 100 kilograms, and the density of gold is 19.3 grams per cubic centimeters. What is the radius of the sphere? Okay, so we have mass and we have density. We have mass is 100 kilograms. We have the density is 19.3 grams per centimeter cube. And we need to figure out what the radius is. All right, and this is a sphere of gold. So we have like a sphere. Pretend this is a perfect sphere here. We have some sort of radius r that we're trying to figure out. Okay, so we need some formulas. First of all, look up the formula for density. So density equals mass over volume. All right, sometimes you can infer the formula by looking at the units. So look at the density is 19.3 grams per centimeter cube. Grams is a measure of mass and centimeter cube is a measure of volume. So you can often kind of figure out formulas by looking at units. But it's good to look them up. All right, so from here we can figure out what the volume is. All right, so volume is equal to mass over density. Okay, if we kind of cross multiply and switch these around. All right, so we got to plug in, but before we do, we got to check our units. So this is in kilograms, but this is in grams per centimeter cube. So kilograms and grams are both units of mass, but they're not the same. Okay, so we got to change the mass. If I multiply this by 1,000, because there is 1,000 grams per kilogram, then we get 1, 0, 0, 0, 0, 0. We have 100,000 grams for the mass of that sphere. Okay, so you got to change the units to match. Okay, so the volume is going to be 100,000 grams divided by 19.3 grams per centimeter cubed. So let's do that division. And we have 5181.347 centimeter cubed. Okay, so this is the volume. All right, now we need a different formula. So I know the volume of the sphere. What is the radius? So the formula for the volume of a sphere is 4/3 pi r cubed. Right? So we can figure out what r is. So we have r cubed is 3/4 pi times the volume. All right, so let's plug that number in. So 3/4 pi times 5181.347 centimeters cubed. So times 3 divided by 4 divided by pi. And I get r cubed equals 1236.9555. centimeter cubed. All right, so now the radius, we're going to take the cube root of this. So cube root of my answer, we get 10.73 centimeters. All right. There we go. Radius is 10 centimeters. That's not very big. Actually, if you think of a lump of gold, that is quite a big lump of gold. It's heavy, 100 kilograms. That's heavy. That's as much as a big person weighs. All right, anyway, here we go for this example. All right, so in this next example, we're going to look at rate of change, average rate of change. So rate is defined by the change of the quantity divided by change in time. So in this example, suppose that on June 4, we measure the temperature at 8 a.m. to be 65 degrees Fahrenheit, and at 10 a.m. is 71 degrees Fahrenheit. Okay, so before we sort of plug into the rate formula, it's good to list. We have like initial time and temperature. So initial time is 8 a.m. and the initial temperature was 65 degrees Fahrenheit. The final time, basically this is the initial and final quantities over the time period we're interested in, was 10 a.m. and final temperature is 71 degrees Fahrenheit. Right? So the rate of change is going to be change in the quantity. So in this case, the quantity we're interested in is the temperature. So we have like T final minus T initial, which is 71 degrees Fahrenheit minus 65 degrees Fahrenheit, divided by change in time, which is final time minus initial time. Right? So this is 10 a.m. minus 8 a.m. Right? So 71 minus 65 is 6 degrees over 2 hours. Right? So it's changed 6 degrees over 2 hours. So the rate will be 3 degrees Fahrenheit per hour. So that's the rate of change of the temperature between those, average rate of change between those two times on June 4th. All right, let's look at another example. A water pipe is mounted to the ceiling, has a leak. It's dripping into the floor below and create a circular puddle of water. It's good to sketch things. You don't have to be artistic. I'm not. So here's like a water pipe. It's basically water is leaking and it's making a puddle on the floor. And this puddle is, starts small and is sort of increasing over time. Okay? It's a circular puddle. So I'm going to sort of look at top view. So let's draw a circle that represents this puddle at a particular time. So it started like with nothing and then it's expanding. Right? This is the radius. All right, the surface area of this puddle is increasing at a constant rate of 4 centimeters squared per hour. All right, so the surface area rate is 4 centimeters squared per hour. Find the surface area and the dimensions of the puddle after 84 minutes. All right, so let's see. If this is increasing at 4 centimeters squared per hour, so we kind of assume that it started with nothing. Okay, so this is, this R is not the radius. This is the surface area rate. All right, so we have 4 centimeters squared per hour, and we're given a time. Time is 84 minutes. All right, we want to change this into hours. So divide by 60. So this is 1.4 hours, right? Because we want to match the units used in the rate. Okay, so this is related to that last equation, because we have the rate is the surface area final minus the surface area initial divided by the time final minus time initial. Okay, so we know the rate is 4 centimeters squared per hour. We're trying to figure out the surface area final. We know the initial surface area is 0. Final time is 1.4 hours. The initial time is 0. Okay, so we can sort of ignore these. So we can solve for the surface area, the final surface area, by multiplying 4 centimeters squared per hour times 1.4 hours. Right, so 4 times 1.4 gives me 5.6 centimeters squared. Right? And then find the dimensions of the puddle. So the dimension means the radius. Okay, so we need a formula for the area of a circle. So area of the circle, surface area of the circle is pi r squared. Right, so we have pi r squared equals 5.6 centimeters squared. So r squared is 5.6 centimeters squared divided by pi, which gives me 1.7825 centimeters squared, and then take the square root. And we get 1.34 centimeters. There we go. All right, and that's it for problem examples for this related to the problem set 1 problems. Let me know if you have more questions. Really participate in the discussion board and come to the Zoom sessions to work through these problems together and with me. All right, bye.